So, let's kick things off by talking about our atmosphere. It's made up of about 78% nitrogen and 21% oxygen, and trust me, that oxygen is a big deal when it comes to keeping us alive. Getting a grip on this mix is super important too, especially if we're thinking about exploring breathable zones in outer space. Now, when we venture out into space, you'll find that molecular oxygen is pretty scarce. Why? Well, it tends to react with dust and hydrogen, forming water ice instead of just floating around. This little reality check really emphasizes the hurdles we face in our quest for breathable air beyond our cozy planet. On a larger scale, we have the heliosphere, which is where the sun's gravitational pull starts to fade. Just imagine if breathable air stretched all the way to this boundary. That would totally change the game for space travel and exploration as we know it. When it comes to the sun, it's not just a big ball of light, it actually vibrates at different frequencies. If those sounds could somehow travel through the vacuum of space, we'd be looking at noise levels that could hit around 125 decibels. That's like standing next to a rock concert. Living in space wouldn't just be about the visuals. It would also mean dealing with some seriously loud sounds. We're talking about noise that could rival church bells or even police sirens. Honestly, it might just drive the residents a bit bonkers after a while. And here's something interesting. In the vacuum of space, there's no friction. This means that planets and moons can orbit the sun without losing any speed. It creates this really unique gravitational setup that's crucial for how everything works in our solar system. But we have to keep in mind that if there were air particles interacting with objects, the friction could be catastrophic. It would cause the surfaces of planets to get scorched, kind of like what happens with asteroids when they blitz through Earth's atmosphere. It's a pretty destructive process. As for the moon, it's actually slowing down because of Earth's gravitational pull. If things kept going this way, we could end up with a massive collision that might literally tear Earth apart. Talk about a dramatic end to life as we know it. Lastly, if we were to introduce a whole lot of mass from air into the solar system, it might boost the density enough to create a black hole. And get this, it would likely be way bigger than the one chilling in the Milky Way. Now that's a wild thought.